And the plates cost $5.19. So what do we get? $6.90. Bless you. And then why did you divide by 2? Because that's how many packs of silverware she got. So what did that equal? $3.45. Excellent. So okay. So another way to think about this, and some of you saw this, 3p, first of all, look at these two equations. What do they have in common? Yeah, that 3p. So that means that I could take this 519 and I can plug it in to 3p here. So I end up with 519 plus 2s equals 1209, right? So now instead of having 2 variables like I did here, I now just have 1 variable. And how do I solve for that variable? How do I solve for that variable? Subtract 519. So I end up with 2s equals 690. And then what's my next step? Divide by 2. Isn't that the exact same steps I just took over here? I subtracted 519 from 1209, and then I just divided that answer by 2, right? And I got the same thing, 345. So this is great that you might be able to reason through this just using arithmetic. But when it gets a little more complicated, we use these equations to solve these a little better. So let's go. We're going to take notes on the 3rd page first, and then we'll come back and look at number 2. Nope. Okay. So steps to solve by substitution. So we are going to write out, do you guys know what an algorithm is? Do you know what an algorithm is? Yeah, it's a process that has like specific and finite steps. So it has, 10 steps or 12 steps or whatever. You could write out an algorithm to make a peanut butter and jelly sandwich, right? Take out the bread, take out the peanut butter, take out the jelly, put the peanut butter on the bread, put the jelly on the bread, put the bread together, got a sandwich, right? There's finite number of steps. That's what I'm going to give you right now is the algorithm, the steps to solve a system of equations by substitution. We're going to write there's 4 steps. We're going to write them down. Don't worry if they don't make a whole lot of sense as you're writing them down. We're going to look at that first example again and kind of think about it that way. So see an example. So first step. Use the relationship between 2 variables to write one in terms of the other. Step 2, substitute. That's why it's called substitution. We substitute Substitute there. Substitute the expression into the other equation. So only one variable remains. And then when we have only one variable remaining, we can solve for that variable. And then finally, once we've solved for that variable, we've figured out what the value is for that variable, we can substitute again. So we substitute the value back into the other equation. So back in to find the other variable. Okay. All right, so we have our steps. We are going to have a quiz this week. I am really thinking about moving it to Thursday instead of Wednesday so we can get an extra day of practice with this. Okay, but I haven't fully decided, but I'm leaning toward that. But substitution and then solving systems by graphing is what's going to be on your quiz. Okay, so make sure you've got this stuff written down. All right. And then we're going to flip back to the front page and let's do number 2 together. So do number 2 together. So we have, so this one we've got Uncle Craig, and Uncle Craig was responsible for bringing what? Chips and salsa. How much does a bag of chips cost? $2.25, and salsa costs $3.50. Good. And how much did he spend in total? Perfect. And what's that next sentence say? He bought 3 times as many bags of chips as he did jars of salsa. Okay, and we're going to use B for bags of chips and J for the number of jars of salsa. Let's first write our equation to represent the total cost of his purchase. So how much did he spend in total? What was the total cost? 41. Good. Okay, what do you think the other side of my equation should look like? What should it be? Any ideas where we can start? Huh? Yeah, what are the 2 variables? Yeah, right, bags of chips and jars of salsa. Huh? Yeah. 225B. Good job. A plus sign. 350J. Excellent. So there's our equation. It's kind of wonky looking, but 225 times, huh? 3 what? So he just bought 3 bags of chips? We don't know that yet, right? So that's why I leave B there, because I don't know how many bags of chips he bought. I know how much they cost, but I don't know how many he bought. Okay? But then yeah, part B is looking at how B and J are related, and it says he bought 3 times as many bags of chips as jars of salsa. So what's my equation for that? What does that look like? This sentence right here, he bought 3 times as many bags of chips as jars of salsa. What's that part as an equation? What do we think? Which one do we think it is? Who agrees with Dylan? J equals 3B. 3 times as many bags of chips as jars of salsa. Anyone agree? Who agrees with Bahati? Ayana. Okay, well, no one else seems to have any idea, maybe? Or just half asleep? What do we think? What do we think? Which one is it going to be? Yeah. So 3 times as many bags of chips as jars of salsa. So is there going to be more salsa or more chips? More chips, right? So that means that if I bought 1 jar of salsa, how many bags of chips would I get? 3 bags, right? So that means it's going to be this one, right? 3 times however many jars of salsa equals the number of chips. So not this one, B equals 3J. Okay, so this was kind of my first step. This was my first step. I write my equations and I make sure that I understand how my variables are related. My second step is to substitute an equivalent expression into the other equation. So can you look at these 2 equations? And remember what I did up here? I substituted 519 in for 3p, because 3p equals 519. So I took this value and I plugged it in for the other one. Can you see how I could maybe do that with these 2 equations? What could I substitute into the other one? What could I substitute into the other one? What could I substitute into the other one? 3? 4? I have no idea what you're talking about. I don't know why you said 4. That's not what I'm asking for. I asked, can I take anything from one of these equations and substitute it into the other one? Huh? Yeah, what could I substitute 3J in for? For J? 3J equals J. For B, I can substitute that in for B. I can take 3J and plug it in for B. So let's rewrite this equation with 3J in place of B. So 225 times 3J plus 350J equals 41. And now let's simplify this. Because look, up here I had 2 variables in my equation. Now how many variables do I have? Just 1, just that J. I mean, it shows up twice, but it's just 1. So let's simplify this because I can kind of put this all together. First, let's do this. 225 times 3J. What's that going to be? Perfect. 675J plus 350J equals 41. And what can I do with these 2 J's? You can combine them together. What's 675 plus 350? 1025J equals 41. Now, how do I solve for J? Divide by what? Yeah, by 1025. So what does J equal, Sean? What does J equal? That was just my third step. Okay, I substituted an expression into the other equation, and then I solved for that remaining variable. And now my final step, because now that I found out what the jars of salsa, how many jars of salsa he bought, but now I want to figure out how many bags of chips he bought. So what do I do to find out how many bags of chips he bought? Where did that times 3 come from? Yeah, and we wrote that equation as well, right? B equals 3J, but J equals 4. So B equals 3 times 4, which is 12. Okay. Let's flip all the way to the back. All the way to the back. All the way to the very back. And I'm going to do number 2 with you. Number 2. Oh, that's not what I want. Number 2. Can somebody read to me number 2? There's 2 equations there, all the way on the very back. Y equals -4. And then what's the other one?
Y equals 4x minus 12.
Y equals 4x minus 12. Okay, I have my equations. Both of these equations are solved for y, which makes this process a lot easier. Okay, this is a really simple example. So when I'm solving a system of equations, my answer is always going to be 2 numbers, x and y, right? Or 2 variables that I'm solving for, chips and salsa, right? What was the other one we did? S&P. Silverware and plates, right? You're always solving for 2 things, okay? So I'm solving for all these problems on the very back. You're going to end up with x and y, right? X and y. This one's really easy. It tells you what y is right off the bat. What's y? -4. But now we got to figure out what x is. Got to figure out what x is, okay? So what do you think I'm going to do to figure out what x is? What do I need to do? Not 0 in for y. Y doesn't equal 0. What did you say, Wyatt? 12 plus x. What do you do, Kenai? -4 equals y. So I take -4 and I plug that in for y, right? Okay, so I'm going to rewrite this second equation. -4 equals 4x minus 12. And now how many variables do I have in there? Just 1. So that means I can solve for that variable. How am I going to solve for x?
Plus 12.
Yeah, I'm going to add 12 to both sides. So those cancel. So we have 4x equals, huh? Yep, 8. And then what? Divide by 4. Divide by 4. So x equals 2. So my answer is not x equals 2. I can't write today. That's not my answer. My answer is 2, -4. It's this. This is my solution, right? My solution is always a point, x and y coordinate. So if I were to graph those 2 lines, I would see that they intersect at 2, -4. So with your last 10 minutes of class, I want you to try to do at least number 1 on the back of that paper, but maybe you could try and do 3 and 4 as well, depending on how much time you have. But number 1 is what I'm going to check. I'm going to have you hand this in at the end of class, and I'll check to see what you've done for number 1. Number 1. It's okay. I'm not going to check to see if you get it right or wrong. I just want to see your thinking. Okay.